Hello everyone, this is Raj from Radical TechArt, your process automation strategist. In this video, I am going to share something extremely powerful with you. This is the Radical TechArt Application Sales Engineer Master Flowchart. This framework will help you to select the correct industrial instrument in under 60 seconds. Yes, just 60 seconds. Because in industrial sales, customers usually do not ask for a product, they explain a problem. And as an application sales engineer, your job is to quickly understand that problem and recommend the right solution. To do this efficiently, we follow a simple 7-step thinking process. Let us go to step by step. First step, identify the parameter. Always start by asking the customer one simple question. What do you want to measure? It could be temperature, humidity, pressure, level, flow, moisture, dew point, or even gas. Once the parameter is clear, the entire solution becomes very easy because every measurement system begins with the parameter being measured. Now, move to second step. Understand the purpose of the measurement. You can ask the customer, what do you want to do with this measurement? Do you just want to monitor the value? Do you want to control a process? Or do you want to record the data? Or do you want automation and remote monitoring? If the purpose is only monitoring, an indicator or data logger may be enough. If the purpose is to control, you may need a controller or a PLC system. If the purpose is recording data, then data logging software or monitoring system becomes very important. Understanding the purpose helps you to design the correct system. Now the third step, understand the application. Ask the customer, where will this sensor be installed? Is it inside a pipeline, inside a tank, inside a room, inside an air duct or machine, or outdoors? Different applications require a different sensor designs. For example, a temperature sensor in a pipeline requires a probe design. A humidity sensor in a clean room requires a wall-mounted transmitter. Application always determines how the sensor will be installed. Now, move to the fourth step. Check measurement range. Always ask, what is the expected measurement range? For example, temperature may be 0 to 100 degrees Celsius, or it may be 0 to 800 degrees Celsius. Pressure may be 0 to 10 bar or 0 to 100 bar. Level measurement may be 0 to 5 meters. Humidity measurement is typically 0 to 100% relative RH. And range is extremely important because it determines the correct sensor technology also. For example, low temperature measurements are usually done with RTD sensors. Very high temperature measurement often require thermocouples. Choosing the correct range ensures accurate measurement. Now, the fifth step, check the environment conditions. Industrial environments can be harsh. So always ask the customer, what is the environment like? Is there high temperature? Is there a dust? Is there a water exposure? Are there chemicals present? Is the instrument installed outdoors? Or is it installed in a hazardous explosive areas? These conditions determines things like IP protection ratings, probe material, and sometimes even flame-proof certification. Ignoring environmental condition is one of the most common causes of instrument failure. So, always verify the environment. Now the sixth step, decide the output signal. Ask the customer, how will this measurement signal be used? Common industrial outputs includes 4 to 20 milliampere signals, Modbus RS485 communication, TCP or IP-based communication, wireless communication, or simply relay outputs. The output signal determines the type of transmitter or controller required and also determines how the instrument connects to PLCs or monitoring system. Now the seventh and final step is determine the monitoring system. Once you know the parameter, application, range, and signal type, you can decide how the system will be monitored. For example, if the customer wants a local display, you may recommend a digital indicator. If the customer wants a process control, you may recommend a PID controller. If the system needs automation, then PLC integration may be required. If the customer wants central monitoring, SCADA system may be used. If the customer wants data recording, then data loggers or software platforms becomes necessary. If the customer wants remote monitoring, then IoT-based system can be used. When you combine all these steps, most industrial systems follow a very common architecture. Sensors connected to a transmitter, then transmitter connected to a controller or a PLC, then controller or PLC connected through communication system, and finally monitored using the software or a SCADA system. This is the standard industrial monitoring architecture used across industries worldwide. Now, let us see how this works in real example. Imagine a customer says, we want to monitor temperature inside a cold storage. Immediately, your mind should start following the flowchart. Parameter is temperature. Purpose is monitoring. Application is a cold storage room. Range may be -20 to 10 degrees Celsius. Environment is humid. Customer may require data logging for compliance. So, the solution becomes very clear. An RTD temperature sensor connected to a transmitter, connected to a data logger, and then monitored through the software. Just by following these steps, you can design complete monitoring system within a minute. At Radical TechArt, we follow a very simple engineering principle. Always remember these 3 steps. First, understand the problem. Second, select the correct sensor. And the third is build the complete monitoring system. When you follow this method, you are not simply selling the products, you are delivering measurement solution. And that is the mindset of a true application sales engineer. Always remember, you are not selling sensors, you are not selling instruments, you are delivering industrial intelligence. You are helping industries measure, monitor and control their processes. And that is the true value of what we do. So thank you so much for watching. See you all in my next video.